Hello. We're back again, and I'll still be discussing about circle theorems, but this time our focus will be about power theorems. Okay, let's have the first one, chord-chord power theorem. So if two chords of a circle intersect, then the product of the measures of the segment of one chord is equal to the product of the measures of the segments of the other chord. So let us use a given figure here to represent the theorem. So again, the product of the measure of the segments of one chord, if we use this chord here, for example, okay, this one. So the product of the measure of the segment, so that would be A times B. So A times B is equal to the product of the measure of the segment of the other chord. So this time the chord containing C and D. So if we multiply that, C times D, that would be equal to A times B. So that's the first power theorem. Okay, now let's have the second one, secant-secant power theorem. So if two secant segments are drawn to a circle from an exterior point, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. Okay, so again we have here a figure. We have two secant segments here, secant AH and secant YH, and they intersect at an external point H. Okay, now based from the theorem, the product, the product of the lengths of one secant segment. So let us use secant segment AH. So based from the theorem, we have if we multiply AH, okay, AH by SH, this is the external secant. That would be equal to the same thing from the other secant segment. So that would be equal to YH times the external secant LH. Okay, now let us write a formula for that. So again, we have AH. This is the whole secant multiplied by the outer secant SH. That is equal to the same thing for the other secant. The whole secant is YH multiplied by the external secant LH. Okay, now let's have the third one. It's the last one also. Tangent secant power theorem. So if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent segment is equal to the product of the lengths of the secant segment and its external secant segment. Okay, so let's go straight with the given figure. We have here a tangent segment LA and a secant segment RA. Okay, so based from the theorem, if we square the length of the tangent segment, so here that is LA. So if we square that one, LA square, that would be equal to the product of the lengths of the secant segment. So the length of the whole secant segment here is RA. So the product of that and the external secant segment, which is UA. Okay, now let's have examples applying the three theorems. Okay, first example, Tangent segment PT measures 8 centimeter. The radius of the circle is 6 centimeter. Find the length of PQ. So let us put some markings on our given figure here based from the given. Okay, so we have here tangent segment PT measures 8 centimeters. So this one is 8 centimeter. And then we are given the radius of the circle, which is 6. So this is 6. And since RS also is, of course, a radius, so this is also 6. And we are looking for PQ. So let us represent PQ as X. Okay. Now we have here tangent and secant. So we will be using tangent secant power theorem. So again, um, first thing is to square your tangent segment. So we will have PT square will be equal to, so for the secant one, the total length, which is PS, times the external segment, which is PQ. Okay, let's substitute the given here. We have our PT is 8, so that would be 8 square is equal to our PS is X plus 6 and 6, that is 12. Okay, times PQ, which is still X. Okay, let's simplify. This is 8 squared, so this is 64. Okay, distribute X inside your parentheses. So this is X squared plus 12X. Let's put them together. So we have X squared plus 12X minus 64 is equal to 0. So check whether it's factorable. So of course it is. So let's factor it. So this is X and X. So we can have 16 and 4. Okay. So of course 16 should be positive. The middle term is positive, and this would be negative. So we have two values of X, which is negative 16 and positive 4. And of course, the final answer, the length of PQ will be 4 centimeter. We don't have a negative length, so we won't consider negative 16. Okay, let's have the second one. Given concentric circles as shown from the figure, what is the length of X and Y? Okay, so when we say concentric circles, it means that the circles have the same center. Okay, so we are looking for the value of, or the length of X and Y. And we have here, of course, two circles. And if you analyze the figure, we have two chords, and the chords extend from the smaller circle going to the larger one. So we cannot just solve for X and Y just by using the smaller figure. So what technique are we going to use? So we will write an equation first using the smaller circle. And then we will write another equation, this time using the larger one. And from that, we will try to solve for the value of X and Y. So let's have first a smaller circle. So we will be using these chords. Okay. So this chords, oops, and this green one. Okay. So let's use these two chords, the red and the green one, okay, to write our first equation. So from the red one, so we will have 2 times y, okay? So that's 2y. And then for the green one, that would be 3 times x. Okay, so this is our first equation. Now, let's write another equation, this time using the larger circle. So our segments will be longer. So we will extend our segments. So we will have now this whole segment. Okay, let's extend them. And then this one here. So we're just extending them. So it covers the larger circle. So let's write now an equation for that. Okay, so let's have the red one, okay, the red segment. Okay, so part by part, we will have 3 plus y, okay, or y plus 3. Times the other part of the segment, 3 plus 2, so that is 5, equal to, for the green segment, so we will have 4 plus x, or x plus 4, times the other part of the segment, so that would be 3 plus 4, which is 7. Okay, let's simplify this equation. So distribute 5 inside the parentheses, so you will have 5y plus 15. And then for the other one, distribute 7 inside, so you will have 7x plus 28. Let's simplify further. Let's transpose 7x to the other side. So you will have 5y minus 7x. And then let's transpose 15 to the right side. 28 minus 15, that is 13. Okay, now we have two equations. We have 2y is equal to 3x and 5y minus 7x is equal to 13. So we will solve it as a system. So let's substitute the first equation to our second equation. So let's rewrite the first equation, solving for y. Okay. So again, it's your choice on how you want to substitute it. So this would be y. Let's just rewrite it, solving for y. So this would be y is equal to 3x over 2. And then let's plug it in to our second equation. So this would be 5 times 3x over 2 minus 7x is equal to 13. So 5 times 3x, that is 15x, all over 2 minus 7x is equal to 13. So 15x over 2 minus 7x, so this is 14x. So 15x minus 14x is an x. So we'll be having x over 2 is equal to 13. So therefore, the value of x is 2 times 13, which is 26. So we now have the value of x. So we can find the value of y just by substituting 26 to our first equation. Let's do that. So y is equal to 3 times, change x to 26, divided by 2. So 2 and 26, so this is 13. 3 times 13 is 39. So our y is 39. Okay. Okay, let's have the last example. So what is the value of x from the given figure? So the figure has 2 seconds. So we'll be using secant power theorem. So for secant power theorem, so we will just multiply the total length of the secant segment by the length of the external secant segment. Okay, same thing with the other side. So let us write that one. So this one will be total length of the segment. So that would be 3x plus x is 4x times the external segment is x. Okay, now for the other one, so the total length is, you will have x plus 2 plus 8, so that would be x plus 10. Okay, times the outer segment is 8. Okay, let's simplify. 4x times x is 4x squared is equal to, distribute 8 inside the parenthesis. You will have 8x plus 80. Okay, so let's transpose the terms on the left, on the right side to the left. So you will have 4x squared minus 8x minus 80. Okay, so we can simplify this. All coefficients are divisible by 4. So this will become x squared, and this one 2x. Then 80 divided by 4 is 20. Okay, so we have x squared minus 2x minus 20 is equal to 0. So we cannot just factor it. So we will be using the quadratic formula to solve for the value of x. So let's do that one. So we will have x is equal to, so our a, so let's write our a is 1, our b is -2, and our c is -20. Okay, so let's solve. Okay, so x is equal to -b, so that would be +2 plus and minus square root of b squared, so that would be -2 square minus 4. Our a is 1 and our c is -20, divided by 2a, or 2 times 1. Okay, so let's simplify. So this would be 2 plus and minus square root of 2 square is 4, and then -4 times a -20 is +80 all over 2. Okay, simplify further. This would be 2 plus and minus square root of 4 plus 80 is 84 all over 2. Let's use the space here. Okay, so we'll have 2 plus and minus square root of 84 is 2 square root of 21. Okay, all over 2. So we can just cancel out all the 2's here. So our x is equal to 1 plus and minus square root of 21. But then since we're talking about length here, we don't have a negative length. So our final answer is 1 plus square root of 21. Okay, so that's it for this video. I hope you learned something. Goodbye.